Welcome back to the presentation on classical geometric construction of full number angles in general. My name is Kimuya Alex from Meru University of Science and Technology. In this video, I'm going to show how to construct angles of magnitudes 22 degrees, 33 degrees, 11 degrees, 147, and some other few angles such as 68 and 122. Or 112, sorry. Now to get started, I'll go to the GeoGebra software directly and we start the construction. I'll have to prepare to raise the necessary tools for use again as I've done the previous constructions. Here I need the compass and here I need to do maybe some geometric transformations. That's okay, ready. I will begin by drawing a straight line between 2 points. Let's this point be exactly 1 for purposely for this demo, and another point will be there. So I'll use the straight line to join these 2 points and I get my baseline using this line. I'll use the compass tool to help me generate a point C that is equidistant between these 2 points that way. I label that as point C and I get it. Next I'll join the point C to B using a straight line that way. I'm going to perform the bisection of this chord, the chord BC, because I already have the curve BC, and again the same bisection to cut across entire bit. I'm going to use the labeling tool to help me label these points of intersection as points D and T respectively, and to get exactly the Alex's figure. I now proceed and bisect the angle EDB. This one I want to generate a point F, and that's the bisection of the intersection between this bisection and the curve BE. So I use this labeling tool to label this as point F. Next I'm going to go further and bisect angle EDF that way. Before I do the labeling, I'll zoom in the figure for accuracy so that I can accurately label the point of intersection with the bisection, the curve EF as point G. Sorry, I have to place it well. And what's wrong? That way. And we get it now. We have the necessary tools to accomplish the construction. I'm going to start with the construction of 22. So before that, I'll produce 32. So I'm going to use these 2 chords using the compass tool, DF, and as usual with point CE as the center, I create a point H. Label this as point H, and again come here, carry this chord DG, label this as point I, the intersection between the arc and the curve in the curve EH. I'll slightly zoom in the figure for accurate labeling, and I come here, cut the labeling tool, place my point I here. Now I zoom out since I got what I wanted. Next, I'll perform the bisection of the angle I, A, P at that point. Change the appearance of this into that color. Right. I use the labeling tool to help me label this as point J. I'll go further and bisect the angle JAB. J, A, B, and change the appearance of this into this. Next, I'm going to label this point of intersection as the point K. I'm going to use the compass to carry the chord. No, before that, sorry. Let's analyze some few facts here. Angle EAB is 30 degrees. It's the bisection of this angle, which is 60. to bring the aspect of 60, let me join this here. Inside here, AC, CB, and BA is an equilateral triangle. So bisection here gives 60. And that shows EAB is 30 degrees. So I can measure angle EAB and I get 30 degrees. Now 30 minus angle KAB, which is 8, I get 22. So I'm going to slightly zoom in the figure, move it this way, and map the point B about point A. I get B prime. Now using the code KE, I can pick it from here, KE, I place my compass here and label this point as point L. Come on, label correctly. That way. I change the appearance of this into this color, for example. Now I want to measure angle LAB prime, and its size should be 22 degrees. It is 22. Now to generate 33, I'll perform the bisection of this angle to give me 11 degrees. This point should be 11. I label this as point M. Now I use the compass tool again to carry this code B prime M or ML, and with point L as the center, I make an arc that cuts the curve LC at another point M. I come and label this as point N. I'll join the point N to A using a straight line that way, and maybe I change this color into that. I can now use this tool, the angle measure tool, to determine the value of this angle, and the angle is 33 degrees. The corresponding angle should be 180 minus 33, and that's 147 degrees. So we have it. It shows angle MAB prime was 11 degrees. Now up to this point, we are being introduced in the concept of angle trisection, the trisection of the infinitely many trisectable angles generated using the Alexis method. So this is the point we are being introduced into trisections, and before we get into trisections, I'll show how to to construct the 68, and I'll perform that 68 construction again from this figure. We already have the necessary tools here. We have 22, into 90 minus 22 we get 68. So before that, I will need to to construct a perpendicular line between the 2 points A and B. What am I doing? Sorry. I'll pick this tool here, perpendicular bisector of these 2 points, B prime and B, and I get my perpendicular here. So I'll change its appearance again into that. I will label this point here as the point O. Now using the code B prime to L, that gives me 22. I place my compass here. I'll change this again into another color. That. Oh, it's confusing. Let me choose another one. That's okay. I label these 2 points either side of the bisector, the perpendicular bisector, that P and Q. If I measure angle QAB, I get 68. If I measure angle PAB prime, I get 68. If I measure angle PAQ, I get 44 degrees. That shows we can divide 44 into 4 equal portions by getting 11. We can divide we can get 34 from here if we do bisection, If you do trisection, here you can get 11. If you do bisection, you get 11. And there are so many other things. This one can be divided. 147, you can construct 40. That's 40 what? 147 divided by 3, we get 39. Yes, 39. That is 3. Remainder 2, 9. So get that 9. We can construct 9 again using Alex's theorem, and we can trisect 147 if only we are able to construct it. Now, this construction has introduced us to the problem of partitioning an anchor into the desired ratio. We can either be interested in dividing an anchor into 4 equal portions, or an anchor into 3 equal portions, that's trisection, or into a certain, the desired ratio, maybe 5 times, maybe the ratio is 7, and so many other things. So we need to divide into 10 fractions. Using Alex's method, we'll be able to solve all those problems. And this presentation marks the end of our demos in construction of all the whole number anchors. Using the Alex's method, with these 2 codes, one can construct any anchor we need. So the rest of the work, I'll leave it. Any question, please use the provided email address in my introduction presentation for contacts. I'll be ready to help any kind of solution needed. I would appreciate any compliment, and thank you for viewing. In the next video, we are going to introduce the classical geometric partitioning of an anchor into certain fraction. We will specifically work with angle trisection in the first introduction to use that as our proof. We'll then go into dividing an angle into the desired ratio. Thank you for viewing again, and remember to subscribe for this presentation.